Good morning. My name is Asif. I'm a solutions architect with AWS. I've been with AWS for around 3 years now. Uh, Prior to that, I was doing software development for a long time. So today, we're going to talk about DevOps culture at Amazon, how software is developed in Amazon.com and AWS, and go from there. So in the next 45 minutes, what you should expect is we'll very briefly cover what DevOps is. How many of us are practicing DevOps today? Great. How many of us have implemented canary deployments? Wow, cool. Nice. And we'll go through that. It was not a trick question, I promise. We'll talk about the Amazon DevOps story, what Amazon and how we transformed our software development. We'll talk about some of the tools we've built around it, and then eventually talk about some best practices. So let's get started. Today, what's happening is startups are taking on giants. And that's primarily because of the agility and the speed that the cloud gives you. Gone are the days when you had to procure a server, go to IT, build up your runtime, install operating systems, and then I am a Java developer. He is a C++ developer. She needs a Node.js environment. And the whole stack used to be like, I remember this in my life where I was forced to use a Java stack top to bottom. And I was like, I can't write UI in this, you know? So it used to hurt, and it used to slow down development. But today, where we are is startups can choose their own layer. Like, I can hire a React developer who is really good in React and develop that layer in React. I can hire a Go developer and build my backend in Go, for example. That's what the cloud enables, and that's where things are. Software is getting in the hands of millions. That's the second big piece that has changed in the last 10 years. Airbnbs of the world have come from, like, basically disrupted the whole industry, where they built a platform where I can go and list my house or my condo for like rent or as a hotel, and they have pretty much disrupted the whole hotel industry. And the incumbents with these large chain hotels are now thinking about software platforms and trying to build this back up again. And that is all enabled through this DevOps culture. We talked about why it matters. This was a survey done by Puppet in 2017. But when companies or enterprises adopt DevOps, we've seen 440% time faster deployments from commit to deploy. As a developer, I push code. And as a developer, I want to see it live. I want to be able to touch it, feel it, and see it working. But when I go through dev, test, stage, and everything, it used to take time because each of these steps, there were friction and blockages. People are spending 44% more time on new features than code. Like, as a rough math, 80% of the time in enterprises is spent towards keeping the lights on. And that number varies, but roughly let's hypothetically pick up 80%. You're left with 20% for innovation or the new things you want to do. All of us in our development teams have these new things we want to do, the next big thing, but we never get to it because we are dragged back to fixing bugs, making sure things are working, the lights are on. But what DevOps, what happens is you get that speed and that agility. Now, let's quickly talk about what is DevOps really. DevOps is a mix of cultural philosophies, how you write code, how you do software development. It's a set of practices. It's a set of things you do as just your daily life, and then tools that enable you to get there. So I'll talk about culture as we go through how Amazon also transformed their culture. But back in the day, I used to sit in a dev team, and I had an ops team. And the ops team was building systems and infrastructure, and I was writing Java code. And all I did was push code, never talk to them. They'll figure out automation and go there. So there was a clear, like a wall standing between. I would throw the code over, and if it works, great. If it does not, they open a ticket, and then this communication forth and back happens. And a lot of inefficiency just comes from there. Because imagine this. If this half of the room is dev and this half is ops, and you don't talk, and you only talk through a TT system, that causes issues. DevOps is really about shared responsibility. You create a team, you own your code. You own your code all the way from development to production. If things break in production, you own it. You get paged at 2 in the morning to fix it. And you know what? If you've written the code at 2 in the morning also, it's faster for you to fix it versus somebody else trying to figure out what the root cause was. You exactly know where the 2 lines were, and you go and fix it, and it goes through the pipelines, and it gets deployed, and it's rolled out to everybody. So imagine there's a security flaw which happens, which somebody, like a 0-day vulnerability that somebody catches at 4 in the morning. The one guy who knows how to fix it, maybe anywhere in the world, and for him it's 5 minutes of work. But today, even today, where we are in the world, in this journey, is there's a whole workflow which kicks off, and by the time this one person gets into the action, it's like an hour wasted or 2 hours wasted. Imagine the risk that you have exposed your platform to. If this culture of DevOps is adopted, what happens is that person gets paged right then, the moment the TT is open, the moment somebody announces it. And Asif wakes up and says, I know this, 4 in the morning, it's okay. I go and change those 2 lines of code, goes to the pipelines, doesn't break anything, and it's fixed. And it's fixed for everybody. So your risk profile of your platform also improves. And obviously, it's about visibility, communication, making sure everybody knows where this is going. Another phenomena that really pushed DevOps and got this agility was microservices. Back in the day, we used to develop code like this, where it's a monolith, and I have my Java code, and I'm basically saying my UI, my backend code, my database layer, the ORM is all tied down together. It's tightly coupled. And God forbid, if I have a schema change, you know what the upstream effect is. Or if I want to change a UI element or add a new field, it was just mayhem. And every single change that I wanted to make caused downstream ripple effect. I need to go into meetings, into Scrum meetings, if I've adopted Agile, and I'm just negotiating. Oh, you know what? This field on the UI causes so much problems on the object layer, these many changes in the ORM layer, so many changes in the schema, and everybody has their different sprint cycles. So you're basically you basically become not agile at this point of time. What microservices did, and Amazon kind of transformed the whole platform into this back in the day, but what it does is, with microservices, you do one thing and one thing really well. So as an example, if you have a shopping cart and you are saying, I want to buy shoes and T-shirts, the shopping cart really knows how to put items into a bucket and pass it on. It doesn't deal with pricing. It doesn't deal with how your ordering is happening. That's somebody else. That's downstream. So you have a clean contract, and you do one thing and one thing really well. What you also do is you bring that independence. So the team who's working on the shopping cart can run at their own speed and deliver the best experience. The order team can run at their speed, and so on and so forth, because everybody has different needs, different requirements, and so on and so forth. So microservices today is a huge phenomenon. Every app, every platform that we talk about, they are trying to transform from monoliths to microservices for the said reasons we talked about. So we talked about culture, we talked about architecture patterns that we could use and how it enables it. How do we practice DevOps? What are the things we need to do every day to make this a reality? So the two primary concepts around this. One is continuous integration, which is basically if you put code in, you need to make sure your code is tested and your code works as a whole of the system. So I shouldn't write like 4 lines of code which really breaks the system. And as I push code into my Git repository or my source code repository, I need to be able to make sure the build firstly is working. Secondly, the tests have gone through, that I didn't cause any regression. And a lot of time we've seen like I fix one thing and then it causes 4 regression tests. Things that were fixed, they come back to haunt us, right? And then we are going back to that. So continuous integration is super important in this conversation. We also need to practice continuous delivery. What we mean by continuous delivery is you need to build, test, deploy all the way to production, like basically dev, test, stage, production. And of course, in a sanitized production environment, you have gates, you have controls that it doesn't go to production, just like that. I've seen customers who have manual controls to flip to production, but all the way to stage, it's all automated. Every single commit, every single PR that you submit is deployed on dev, test, stage to see how it reacts. Environments are different. Environment variables could be different. Data could be different. Like in dev, probably if you have PII data, it's obscure, so you don't test for it, but sometimes you catch it in stage. And those things are super important. And then finally, continuous deployment and delivery, which we talked about, is the name of the whole effort. Once you have done this, what have you achieved? What you have achieved is every single commit is tested, verified, and before it touches your customer, somebody has seen it. People still are trying to get off manual into production, into automated pieces. The goal should always be automate as much as you can. You're writing unit tests, integration tests, you have build servers, you have Docker now to completely compose the environment, abstract the environment away. Use those tricks and techniques to make sure these things are abstracted and it doesn't cause the brittleness that comes with every environment moving. The other big piece is model your cloud resources as code. Use infrastructure as code. It's been there for 10 years. This is the state of the art. If you have modeled your infrastructure as code, you have taken away a lot of frictions from the ops team, where now the ops team can actually focus on building more things. You should definitely track, analyze, improve on the code that you have written, on the learnings you have, and go from there. You have to understand how your code behaves in production. So there might be situations where in stage I've tested with load test and things like that, but I've never hit peak traffic. But come prime day, I hit peak traffic. How does my code behave? If I've written a multi-threaded application, how does those threads behave in production? You won't know it till there. So it's very important to have that traceability back and that feedback loop in. So we've talked about what DevOps culture is, what practices, what tools and things you can do. What does it give you back? And these are like things you already know. It gives you back that constant communication back between the teams. There's no more throwing over the wall. Your ops and dev is a part of the same team. Your goal is same, your mission is same. You get into this rapid delivery. You get into this speed, the agility we talked about. Your code is hopefully more reliable, secure. It scales. If you do infrastructure as code really well, the scaling part comes in through the cloud, and you gain speed. So having level set what DevOps culture is, what practices you can adopt, let's take a look back into how we did this at Amazon. We were organized in 2001 like this, as a monolith. We had application teams, we had ops teams, we had a completely monolithic stack. But in our journey towards creating this new platform, we created a microservices-based platform. By 2009, we were completely microservices. So if you go to Amazon.com today, the website, that's powered by a number of microservices. Each of the features that you use is probably a microservice or a number of microservices like shopping cart and ordering and listing and things like that. We also changed our DevOps culture, or dev culture and ops culture both. We went to 2 pizza teams. The philosophy is, if you cannot feed a team with 2 pizzas, and you can argue about the size of the pizza, so you have to big a team. Your maximum team size should be the size of or the number of people that can be fed like to their content with 2 pizzas. And that gives you a number or the limit of number of people. And this is really a communication model story. If we all sit in one development team, there's a communication overhead. But we still need to be a team to deliver stuff. So what is that optimal number? So we came with this 2 pizza theory, and let's say that's the right number. But again, the pizza sizes can vary, and you can decide based on your agility and where you want to go. So things were really going well. They were better under this model. We were releasing faster, but we felt we could still improve. So we did a survey in 2009 to find out where are those inefficiencies. We've built this new development environment, development culture. What can we still do more, like continuously improving, sticking to the theme? What we found was we were still waiting. So you write code. I'm a dev. I wrote code. I wait to build code. And when it's building, I wait again to deploy code. And these were different people doing things. And then most of the communication was happening through TTs, through trouble tickets. And it was taking weeks to deploy. For us, this was something we needed to improve on. So what we did was, and I'll show you how we did this. By the shared responsibility model that we came through and the pipelines we built, and I'll talk about pipelines, we were able to reduce this weeks into hours. And we built tools to automate this. And going back to earlier what we said, you need to automate this. You can have a great culture, you can have a lot of nice practices, but there's still human lag that you have to overcome. And you build tools to automate this. The one tool that is super important is pipelines. This is automated actions and transitions. So I check in my code, a build server picks it up, builds the code into a binary, deploys into the dev environment, runs all the tests, and then comes back with a yes or a no to say that my code is really working or not. A good practice for which we implemented back in my old job, which I implemented, was a +1 by somebody who knows the code. So I'm a new developer. I came in, and I changed code. I pushed code. That code works. It builds. It doesn't cause any regression. It's tested. But you don't merge that into the master branch till an architect or a lead who really understands the code, who spent time writing this code or looking at this code, can do a +1. Some people also do +2 to make sure that you have code review and code verification in place so that you don't break the production system or introduce any performance lags or any unseen errors. It helps you get like simplification and standardization across the platform. That's the big one when you go to code reviews and things like that. So this has continued to improve over time. In 2014, we had thousands of service teams across Amazon building using this philosophy. We are building using microservices. We are practicing continuous delivery. And what it means is we are doing 50 million deploys a year. That's how many deployments are going on with Amazon. That's an gigantic, enormous number to think, even for us to think about a few years ago. That's how things are moving. And every year we do this survey at Amazon for devs. If I'm pretty sure you guys are doing development surveys, you're asking questions of your developers, who is happy, what is working, what is not working. The one thing we found is the pipelines, the continuous delivery directly translates to happy developers. That gives them or that takes away the friction from them of managing, building, deploying, and also gives them an answer quickly. If I push code, I've written my test cases really well. If I'm doing test-driven development, great. If not, I've written my unit tests. But it gives me an answer quickly, whether this works or it doesn't work. Do I need to go back and fix it or not? Or will I get paged at 2 in the morning or not? So there's a direct relationship between the two. But this is a lot. The question I get asked by a lot of customers when we do this presentation by executives, architects, developers is, that's a lot to change on day one. Where do I start? This is so much to do. Typically, the answer varies, and it's, I hate to say it depends, but it depends. The key part is to take baby steps or small steps toward this journey. And what it means is maybe you are culturally ready and you need to adopt practices. Maybe you're culturally not ready and you need to go back and use the tools to push through culture. So if you introduce a new build tool or an automation tool, that could be a vehicle for change. That, hey, this works so much better. I remember the day when 2008, we were all used to using Perforce and SVN, and we all know all the good stories around there, and we changed to Git. A team of 30 people changed to Git. And there was a guy, and Git promises you small commits. You need to make your commits really small for the reason that you don't break code or you don't cause big impact on the production code or the downstream. So I had a developer. I love the guy even now. He had 200 commits sitting on his laptop, and he pushed onto the master branch, and it broke everything. And we were doing a deployment in the morning to the CEO of a very large OEM. And it took us, four of us took all night to just roll back, stash, commit, roll back, stash, commit, roll back, stash, commit. And that's the pain that we went through to learn that that's not the right thing to do. If you have, and no offense to the guy, or we were all learning together. We didn't have a dev branch. We didn't have a test branch. We just had a master branch. We were all learning. That's how Perforce was built. So we just used that Perforce or current knowledge into things of the future. And it broke, but we learned. And we were able to roll back. But what that learning told us is we were not ready for a tool like Git. We needed to take our devs back and talk about really Git. The model that you can have a local shadow tree repository on your laptop was very difficult to fathom back in 2007-8. Now, how do you do that? And it took us a while to grasp that. Then the build environments came through, the automated scripts came through, and everybody knows integration tests and acceptance tests and all that. But how do you build all this together? So the real answer here lies is you need to look back to yourself in your teams and ask yourself the question, out of everything I heard, these are the two things that I can do now. I can probably maybe get devs and ops together in a room and reorganize my team to make them talk more, or arrange a meeting where they are communicating. Or I can adopt a tool, or I can actually build a pipeline because I've got everything else figured out. That's how I would start if I had to start. But there are 5 major pieces that we talk about, and this should not be new to anybody. In development, we have source. We check in source, such as Java or Java files. We peer review codes. We talked about this. We build. We compile code. We take those the human readable language and translate that into machine readable language. We do unit tests, style checkers, code metrics, and we create images like container images or push functions. Style checkers, or having a standardized style, is so super important. Whenever a new developer onboards, reading code is like a lot of time spent. And if everybody's writing with a different style, it becomes really hard to get that going. So it's important to enforce a style or standardize across a style that this is how we write a servlet, this is how we write a plain old Java object or a bean or things like that, right? Test. I cannot emphasize more about test. Automate your tests. There is a thing going on in the Silicon Valley, and I'm from the Silicon Valley, so I get to bash them a little bit. Deploy to production straight. There is a few at the edge, 2 developer shops trying to push. It's absolutely the wrong thing. You are just setting yourself up for big, big, big problems. You need to test. You need to test on your unit, on your dev environments, on your test environments, on your stage, and you have to make sure things work, even from a security perspective and other things. We talked about deployment a lot, continuously deploy, and then monitor, because all of this will improve when there's a feedback loop from what is happening really out there. Monitor your code in production. Make sure you learn from there. Make sure the next time that your team is writing code, you are making sure, oh, you know what? People actually use my product in a different way than I thought. People are not going through the listing in a scroll down. People are going by zip code and jumping zip codes. That's a completely different usage pattern. And it's important to understand what's going on and how people are using the system that we are building. We talked about the release process levels, how things go. You write your source code, you build, that's continuous integration, and then you have gates to deliver it all the way to production, and then you are continuously deploying. We've built a number of tools around this. So when we looked at our development, a lot of these tools come out of our development when we looked at how we do code, and we thought about externalizing these services. So for source control, we have AWS Code Commit, which is a managed Git repository in your AWS account. So you live within the VPC, within the firewall and security profile of your VPC, and it's completely Git compatible. You have PRs, you have pull requests, you have code reviews, you have other things which you can do. You're +1 now, I think, also. The second part is, which is super, super awesome to me, is AWS Code Build. AWS Code Build is a managed build environment. How many of us love Jenkins plugins? Okay, like there are few people. I don't love Jenkins plugins because you know what? Every time it breaks in production. Like I'm deploying and it breaks in production. So Jenkins is improving, no ding to them, but the idea is I wanted always this managed environment, things that just work. A build environment is one of the brittleness or the friction points that has always existed in the last 10 years. So with code build, what happens is you write a build spec file. You tell the build environment, go build this, go do this on a Docker environment, do Maven builds and things like that, run a test, and it does all this in a managed environment where you don't care about keeping the lights on. You don't have to go stand over the shoulder of your ops guy and say, why is this really not working? Because it just works on the cloud. You can also integrate third-party tools. For example, you have code checkers, you have testing tools like Load Runner. You can integrate all of that into the pipeline. Then we have also Code Deploy. We actually externalize Code Deploy, which is basically helps you to deploy your code onto your production EC2s and other environments like Lambda. All of this, these are multiple small steps we need to make sure that the whole story comes together, is orchestrated through a pipeline. A pipeline, as I talked before, it's basically a workflow. I push code. When I push code, the pipeline should auto-detect there was a new commit and pull it. And then the next step I can define, it's a build. So I go build it. And then after build, I can go and deploy, or maybe put a gate in that you can have branches. You can say, OK, first deploy to stage. If everything passes, green, then go to first to dev, then to test, then to stage. And then before you go to production, I want a manual approval. You can't go just like that. So somebody as a lead goes in and says yes, and then it goes there. You also have X-ray and CloudWatch to make sure your logging, tracing, monitoring is there. So when we talked right at the beginning that startups are able to do this so fast, this is how it's happening. You have the culture in place. You have some practices in place. You have basically created that environment. And then you're using the best tools. You don't have to use these tools. You can use other tools. You can mix and match the tools that you're comfortable to. But what it does is it gives you that agility. Now imagine as a 5 people startup, I don't have to worry about getting a Jenkins server up anymore. I don't have to worry about doing infrastructure as code or how to configure a load balancer. I just write it once and it always works. That's where your speed comes through. One of the things I'm super excited about is Code Star. How many of us have looked at AWS Code Star? A few of us at the back. Cool. So AWS Code Star is this command and control center, if you may, where all of these pieces come together for me as a developer. As a developer, I have to jump between tools. Even in this pipeline, I have to go from Git to code build to someplace else, even while I'm developing on the AWS cloud environment. With Code Star, things come together for me. I can visualize everything together. I have sample examples that I can use to jumpstart my development, and it's integrated back to all of these tools. The other thing I'm super excited, and I develop like that now, is using AWS Cloud9. It is a cloud IDE. I can create a Lambda function right from my cloud IDE. I don't need to have a heavy Eclipse on my laptop anymore, and so that my laptop doesn't have performance issues. I can write code, I can debug code, and I can deploy code onto the cloud or through a pipeline using Cloud9 and Code Star. That completely changes your development experience from having these 10 tools which work differently to this one simplified view and simplified tool set that you could use. So that's the tool sets we built. Let's talk about some best practices, right? So testing, we talked about why it is important. But there are some things in testing we need to be really aware of. For example, you want to confirm the desired functionality. Functional tests are super important. A lot of time, we'll write unit tests to test code, but not functions. What is this code really doing? Is this taking an order, or is it putting a shopping cart in a state? And it's very important as engineers for us to test through functions. Of course, you catch programming syntax errors, you standardize code patterns, you reduce bugs, but you also try to make your applications better. And what it means is make your applications more performant, more secure, more functionally correct. And that I think is super important. But the question I get asked a lot is, okay, great, I need to write all these tests, but how do I divide these tests? What is the strategy? This is one of these strategies that we've seen getting used, is where 70% of your tests written for code is unit tests, just to test the functionality, making sure you've written correct code. 20% is service, the service layer, and 10% of your tests is testing the UI. A lot of time, the UI testing is at the back burner, but that's your first input or intake from the customer. If your customer is not, like we live in this 30 seconds attention span these days, if you're not able to get to your customer in 30 seconds and things break and they look ugly on the UI, or you touch it and it just does something you don't understand, you've lost the end user. So it's super important to focus on that. You can automate this a ton today. So unit tests, you can include, like when you're running your build, you can include Maven as an example of a tool to run all these tests, to basically do this regression, do this automation, and make sure your tests are working. You don't have to do this manually. For the service and UI, you have third-party tooling. So for the UI, we used to use Selenium Grid back in the day. So there are other tools that have come through. And you can integrate all these tools into your pipeline. So you can automate your end-to-end testing to a level that you feel confident releasing these. Some of the best practices we've learned as we went through, the one thing which is a must is you have to go and practice continuous integration and continuous delivery. You have to commit more frequently. You have to build on every commit. Your commits have to be small. If your commit is more than 20 lines of code, no architect, no lead is actually reviewing it. Because I don't know how this thing maps. Even if I know my code base of 200 lines or 2,000 lines, if you send me code which is more than 10 lines, there's very hard for the architect or the lead to comprehend what you're trying to say or do. Make sure you are ramming things out. You're actually documenting your code. If you're thinking about doing something, make sure you have to-dos there, so that somebody reviewing the code, somebody who reads the code behind you, can actually know, oh, this guy really wanted to read from a secret parameter store, but he ran out of time, so he's doing it a different way. But that's the way to do it. So what you've done is you've made your code more maintainable, more scalable from a human perspective, and keep going from there. Everything that is code or relates to code has to go in a repository. You can application, infrastructure, documentation. If it's not in the repository, it's not in a Git repo or a different repo or a source control system, it should not go to production. And the reason for this is, the moment you put this in a repository, you have actually created this DevOps culture and principles and practices in place where you can have one place to go when you're looking at code. Imagine storing your design docs in one place and your ERDs in another place, and the person is just trying to figure out, and then there's a proliferation of wikis. I go to this wiki for this, and sometimes I also live like this. It's hard as a developer. Start with gated promotions. That's the easiest thing to do. Build up to the continuous deployment. None of us learned how to ride at 50 miles an hour. We first learned to drive a car, how the pedals work. We learned how to hold the steering with somebody trying, our dad or somebody else trying to make sure that the steering doesn't go this way. Take those steps and get it there. And once you have a high level of confidence, and then you push for it and go from there. And I asked this question right at the beginning, how many of us are doing canary deployment? And I saw a couple of hands at the back and in the front. That's awesome. There are different strategies of deployment. There's blue-green, where basically I deploy code into a blue environment, which is a live environment. But I don't deploy all my tests into that environment. I go to a green environment, which is my development and staging. In my green environment, only my team or the internal team is getting access. It's locked down by VPCs. Nobody else can access. Once I feel confident, I can promote it to blue or the live section so my customers get it. Canary is the next version of that. So you can actually throttle this up and down. You can say, I want to deploy my code only to this geography called San Francisco. Or I want to deploy this to only this microservice, which is the big 500 microservices I have. I want to deploy only few changes and see how people react or how this thing reacts in production. So in production, you actually throttle the traffic from 10, 15, 30, 40. And then if it performs well, you actually throttle it all the way to 100. If it does not, you can roll back and go back to your old version. So those are strategies you should use. But again, take small steps towards that. Test, deploy to an availability zone. Start with an AZ that is more blessed, but then also from everything fails all the time. So make sure your code is fault tolerant, highly reliable. So you're deploying to 2 AZs. You can switch over between AZs and things like that. And then eventually deploy to a region. Further best practices. I talked about this a little bit. Code reviews are super important. I cannot stress on the importance of this because a lot of times a second person looking at your code can tell you things which you will never catch. It happens to me. There's a whole concept around pair programming that came out, where 2 people are coding and somebody's watching over the shoulder. There are times where people have caught null pointers for me or variables which are null for me right off the bat. And it's like, why are you doing that, Asif? I'm like, yeah, thank you. And you go from there. So you learn together. You make sure your code is improving. And going back to what I earlier said, your small commits enable that. If you break down your big functional requirements into smaller functions, it enables you getting there. Style checkers, as I talked about, it's super important. Can somebody else update it, fix it, maintain it? This is about empathy, having empathy for your whole team. Sometimes a new person comes in. Sometimes somebody takes a new module. Sometimes your code is transferred to another team. So having that empathy, that if I was in that person's shoes, how would I feel if I got this code, which I have no idea how it understands. I've written my own code, which follows my style and nobody else's style. So it's super important to have that. Auto rollbacks is the quickest recovery mechanisms. So when you implement blue-green, canary deployments, you can roll back very quickly. You can throttle back, and you can say, OK, go back to the old version. Because what you have done is you have reduced your blast radius. If you find a defect, the security example that we took, 2 in the morning, somebody finds a 0-day vulnerability bug. What do you do at that stage? You can't let it stay out there in production because it's causing risk. You roll back to your earlier version, which didn't have that, or which fixed that. And then you page your developer, the guy who actually built this code, and he can fix it, and then you promote your code up there. So it basically creates this environment where you're always secure, where you're always performant, where you're always putting your customers first. Your customers always come first. And your customers are your end users, are your business users, are your ops people, and all of that. And if you have ops people in the room, your customers are your devs people, right? So make sure that whole thing is going well. Analyze what you have, how your code is working in production, when an error happens, when a bug happens. How many of us are actually logging things? How much of your code is actually logging info, debug information that somebody else debugging can understand? Try to use dashboards if you can to see what is happening now. What does normal look like in production? Like, is this normal? What does peak look like in production? Now, if there is an event that happens for some reason, like we have a spike in sales, how do you react to that? How is your code actually performing? Do you need to deploy more instances, or does your code auto-scales? These are small things, but they give you returns in multiple order of magnitude higher. So everything I talked about, you can find on awsamazon.com/DevOps. There's a number of blogs. There's a bunch of partner solutions, third-party tools I talked about, a bunch of resources, white papers, and things that you can read about. There's a white paper on CI/CD, I believe, that you can read through. But at the end of the day, it's about picking the piece that works for you and using that as a pivot to get to the next stage and keep moving forward. The first place I start, where I'm looking for AWS-related DevOps conversations, what should I do? I go to AWS DevOps Blog, and this literally is one of the blogs that I know the guy who wrote it is a friend, but this was one of the biggest customer problems. Like, this blog was written for a customer that, hey, how do I do cross-region, cross-account pipelines? Because my dev account is different than my stage account and test account, and I'm trying to deploy from US West to US East. How do I do that? And this blog actually talks about that. It has code behind it. It has the cloud infrastructure, the CloudFormation templates behind it. So you don't have to reinvent or learn everything from scratch. There's a GitHub repository called AWS Samples that you can go and look at. So you can learn from it and then customize it and use it the way you want to use it and accelerate your journey. Hopefully, this has resonated with you guys. Hopefully, you guys can pick pieces of this and go back to your jobs like today and try to implement. No, I'm just kidding. But give it a thought. Probably you guys, some of you are already doing a lot of this. Probably some of you are early in the journey. But you can actually get to this culture of DevOps and build this small startup within your own organizations, which can deliver a lot more innovation and a lot less keeping the lights on, you know? So each of you are pioneers. Each of you are those forward-leading innovators who can actually change or disrupt the way things are done. So think through that and reach out to us if you need to through the normal channels, and we're more than happy to help. I've got 5 more minutes, so I can take a couple of questions if you have any questions. Okay? Go ahead.
For the testing component of the pipeline, that's where security can be implemented. And how much impact would security testing affect this
Okay, so the question is, will security testing be a part of the pipeline, and how much will the security testing impact the pipeline? So absolutely yes, your security tests have to be a part of your pipeline. And again, at the end of the day, the developer who writes the code writes the security test. And if you automate that, it actually gets you much more efficient, and your pipeline actually gets easier and faster. So with the build environment, you can actually execute your security tests off the bat. There's some things you cannot do, like you can and cannot do, like penetration tests and things like that, like depending on how your organization is organized, what kind of SLAs you have to meet. So you might pick and choose how much you want to implement, but absolutely security tests are a part of the pipeline. Okay?
So on your microservices slide, you showed an 8-year span between monolithic to microservices transition. Is that really how long it took? And can you talk about what your processes were? Did you replace small components of your monolithic, or did you just do a complete replacement?
Yeah, so it was a continuous learning exercise. So it took us, like, it talks about 2001 to 2009, that's a journey, but we continuously improved in small components, refined, learned, did the surveys, learned something back, went back, changed things more. So it was a continuous learning process. Your question around how much time it takes for transformation, which is really the question you're asking, depends. It depends how ready you are. It depends if the organization is ready, if you have been upskilled, if the tools are causing friction. So you'll have to take a look back and make a plan which actually works, and not make a 4-year plan, because by 4 years things have changed. Make a small plan for the next 6 months, 12 months, and see if you can achieve that part, and then take the next step, So, yeah. Cool. Thank you so much for coming in. Thank you for listening. I'll get you after the thing. Thank you so much for coming in, and have a nice rest of the day.